today's video, I am going to go through the together problems for the first part of Equilibrium. Obviously, if you have not watched the videos on these first sections, it certainly is in your best interest to do that. As you can see, there's not a ton of content in Chapter 13, so we will move through this pretty quickly, and then we've got that unit test coming up at the end for Chapter 12 and Chapter 13. So this video I'm going to cover number 19, 20, and 24. Okay, is what I'm going to cover here. All right, so if you look at the way the questions are written, it talks about what's called the equilibrium constant. It wants to write the equilibrium constant expression K. Now you'll notice we're dealing with a capital K here. Okay, apparently won't let me write on that. Capital K, not lowercase k for kinetics, capital K for equilibrium. So we're making a shift. For each of the following gas phase reactions. Now gas phase is going to be really important for equilibrium, so you want to take note of what that is going to look like. Now again, if you have not watched the video, to kind of remind you of how we do this, equilibrium expression is usually written this way, where it's essentially a reaction, it's a quotient, where you put the products, the concentration of the products over the concentration of the reactants, and that's where we have products over reactants for this stuff. Okay, so all we have to do is, the good news is all we have to do is take these reactions and write them accordingly. So for 19A, let's see if we can't get a pen back here, number 19, letter A, again, you simply put the reactants over the products. So you've got capital K, which is going to be equal to the concentration of the nitrogen monoxide raised to the second power, or second order, because it has a 2. This is from the coefficient in the balanced chemical reaction. Okay, if you look back at the question, that 2 right there is why we put it up there. Okay, so there's the first one. We've got NO raised to the second power. We also are going to have nitrogen and then oxygen. Okay, and that's it. That's all you have to do when you write what's called the equilibrium expression. So for letter B, we're going to do the same thing. We're going to take the products. Capital K is equal to nitrogen dioxide, and it's going to be to the second power again because that's got a 2 in front of it for the coefficient. Now this one just happens to be one product and one reactant, so that's all that ends up in our balanced equation here, where we have N2O4. Okay, and you go through the same process. So for letter C, capital K, and even though there's more reactants and more products, SiCl4, it's only got a 1 next to it. One thing, if you're watching this video, you need to make sure that you write these problems down. When I do together problem videos, and that's the expectation, your evidence of watching them is that you have the solutions written down. So if you have not done that, you need to pause this video and go ahead and get everything jotted down, and because I will be looking for it the next class when I check off your homework. Okay, SiH4, Cl2 raised to the second power. And then letter D, capital K, you've got phosphorus trichloride, raised to the second. You get the point. Hopefully a lot of you were like, okay, we get it. It really is that straightforward when you are just writing what are called the equilibrium expressions. And as a reminder, one of the biggest mistakes that people make on these is that you need to make sure it's always a ratio of the products go on top and the reactants go on the bottom. Okay, that's probably really the only mistake. And again, I'm going to point out that in all of these problems that we started with gases. Okay, now the next one that I want to do together is going to be number 20. Now the good news on number 20, you'll notice that we have capital K and what's called Kp. Now, the thing when we look at equilibriums, sometimes we look at concentrations, which is going to be why we wrote all of these here with the brackets. That would be molar concentration. But with gases, sometimes we also can look at pressures. So one thing that I want to mention is that sometimes in an AP, plain old capital K sometimes is also referenced as Kc. And what I remember the C as in Kc is concentration. Okay, so if we were to switch these now and write them as pressures, I'm actually only going to do the first one because it really is that simple. Actually, maybe I'll do letter B here so that we can keep it all on the same page. So for number 20, it wants you to write the partial pressures. Well, so the only difference for number 20 is that we're going to use KP. P is going to stand for pressure. And all you have to do for these is, instead of having concentration raised to the second power, you do partial pressure. So you would have the partial pressure of, where am I looking at? Letter B. Nitrogen dioxide raised to the second power over the partial pressure of the N2O4. That's it. All I'm doing is replacing concentration values with pressure. Okay, that's it. So that's letter B right there. Letter D would look like this. And we'll only do B and D on this one just because it really is that simple. You would have the pressure squared. It's still products over reactants, so we're not going to switch it that way, times the pressure cubed of diatomic bromine over the pressure squared of phosphorus tribromide. And then again, where am I getting these 2's and these 3's from? Well, one, there's our 2's and 3's here, but also there are the coefficients in the balanced chemical reaction. Okay, so you've got P Cl2 raised to the third power. Okay, so that's number 20, Kc and Kp. It really is that simple. Don't overthink it. All right, the last one that I want to do together for you is number 24. And for number 24, what you have to do, if we go ahead and read the problem here. Dun, dun, dun. Okay, for the reaction, you've got nitrogen reacting with chlorine to give us nitrogen trichloride over here. All right, an analysis of an equilibrium mixture is performed at a certain temperature. They're telling you at certain temperature because, again, capital K's are going to be temperature dependent because it will change the kinetic energy of the materials. It is found that the concentration of the product is 1.9 times 10 to the negative first molar. The concentration of the nitrogen is 1.4 times 10 to the third, and the concentration of the chlorine is 4.3 times 10 to the negative fourth. All they want you to do is calculate capital K. So now we're going to do the same thing we just did, where we're going to write the capital K expression, and then we're going to plug those numbers in, and we're going to just solve for it, and that's it. Okay, so part of the reason I'm doing the together video for some of these is on things that are really, really straightforward. That's just a matter of you spending time with it. You know, it can certainly save us face-to-face class time to do it this way. Okay, so you have NCl3 raised to the second over, you've got nitrogen and the chlorine raised to the third. Again, where did I get that from? These are my products. Whoa, that was really ugly. Let's try that again. This is a ratio of my products over my reactants. And again, those 2's and those 3's simply came from the fact that in the balanced chemical equation they had coefficients. That's it. So now all I have to do is plug and chug those numbers in. So I'm going to put 0.19 squared over 1.4 times 10 to the negative third. Whoops. And you've got 4.3 times 10 to the negative fourth cubed. And then it's a matter of plug and chugging. And here's the great part. Remember lowercase k in chapter 12 had all those awful, not awful, but all those really tough labels, right? It would change based on if it was first order or second order. There's no units for capital K. So when I plug and chug this, I don't want to show this message again. 2 sig figs, it's going to end up being 3.2 times 10 to the 11th, and that's it. No units. Okay, which again, remember, if you're watching this video, evidence that you've watched it, you need to be able to write that stuff down. So that is the first set of together problems that go along with this information at the beginning. You also need to do 27, 28, 29, 31, 32, and 21 as well for this first homework assignment. And then we'll get into 13.5 and 13.6 with solving equilibrium problems.